Now, to solve this indicial equation, as I've always advised, the relationship between terms is very important. And the solution required for this is first to dissociate the powers with binomials, the binomial powers, which we can see here, and we can see another one here, and we can see four of them having the binomial powers. So we're going to dissociate them, and that will be the first step. So we have 2 raised to power 2n minus 3, 2 raised to power 2n. To dissociate it is the reverse of the product rule, the rule 1 over there. Multiply by 2 raised to power minus 2, open bracket, 3n minus 2 times 3 raised to power n times 3 raised to power minus 2. The product rule. When we multiply this again, we add the power. Adding the power, 2n plus minus 2 becomes 2n minus 2. The same thing we have here. So that's the power rule over the same thing at the denominator. Multiply by minus 4, open bracket. Now this process, I've already simplified it here, and that is the simplified form of it. I don't want to go over it here. It will make me to replicate the steps. So I'll just replace the solution there. I will replace it here to 2 raised to power 2n. Then I will also dissociate it. That will be times 2 raised to power 6 minus 2 raised to power 2n. Now what we need to do here, we've successfully dissociated the powers that are binomial. Now the next thing is to factorize. We will realize that in this bracket we have this and this to be common, and we also have this and this to be common here. So we're going to factorize the bracket, the common terms in the bracket. So we have 2 raised to power 2n, 3 raised to power n, 2 raised to power 2n also here. So let's do that. We have equals to 2 raised to power 2n, open bracket, then 1 will be left here because we factorize the whole thing here, so we are left with 1 minus 3 times, this is gone, 2 raised to power minus 2. Then here also, the relationship between this bracket and this bracket is multiplication. We must have that in mind. Then let's factorize what is common here, 3 raised to power n, open bracket, 1 minus 2 times 3 raised to power minus 2 divided by, we already have 3n here, 10 times minus 4. Then we have another thing coming outside, that is multiply by 2 raised to power 2n, open bracket. Okay, we are left with 2 raised to power 6 minus, okay, 1. Now we'll realize something. The relationship between this and this is multiplication, this and this is multiplication, this and this, and even this bracket is multiplication. So 3n can cancel 3n here, and we have this to also cancel this. So we are left with no variable any longer. So now we can now bring it to be 1 minus 3 times 2 raised to power minus 2. We can use rule, that will be rule 3 over there. So we have this to be 1 over 2 raised to power 2, which is 4, open bracket. Then we have 1 minus 2 times, that is 1 over 3 raised to power 2, that is 9 over, we have 3 left here, that's 1 over 3 raised to power 4, that's 3 times 3 times 3 times 3, that's 81, open bracket, 2 raised to power 6, that is 60, that should be 64 minus 1, close bracket. So we have this to be 1 minus, we must, okay, let's draw a line here, and let's put the boundary here, so that we will conclude this question here, this problem here. And this becomes 3 over 4. Okay, we're going to use a calculator. 1 minus 2 over 9 over 1 over 81, this is 63, that becomes 1 over 81 times 63. equals to 1 over 4. That's 1 minus 3 over 4 is 1 over 4 times 1 minus 2 over 9 is 7 over 9 divided by 1 over 81 times 63 is 63 over 81. So this is reduced to 1 over 4, 7 times 9 divided by 63 divided by 81. So 9 can divide this and 9 can divide this. So 963 is 7 times. 9 in 81 is 9 times. So we can see from here that these cancel this fraction. So we are left with 1 over 4. And that is the final answer. Thank you.